capacity, and specific heat capacity. We will also learn about their applications in HVAC. Let's consider two water tanks, Tank A and Tank B. Tank A has a length, width, and height of 100 centimeters each, while Tank B has a length, width, and height of 50 centimeters each. Both Tank A and Tank B are filled with water at a rate of 1 liter per minute. In Tank A, the water level to rise by 1 centimeter, it will take 10 minutes. But in Tank B, the water level to rise by 1 centimeter, it will take only 2.5 minutes. This is because Tank A has a larger water capacity, so it takes longer for the water level to rise by 1 centimeter. Tank B has a smaller water capacity, so it takes less time for the water level to rise by 1 centimeter. The same applies to heat capacity. For example, consider two materials of 1 kilogram mass, lead and aluminum. Aluminum is a material with high heat capacity. This means it can store more heat. Lead is a material with low heat capacity. This means it cannot store as much heat. Let's assume that both of these materials are at a temperature of 25 degrees Celsius. Now, let's apply the same amount of heat to both materials. When heat is applied, it takes more time for the aluminum material to increase in temperature from 25 degrees Celsius to 26 degrees Celsius than it does for the lead material. However, the lead material will quickly reach 26 degrees Celsius from 25 degrees Celsius. Similarly, for each temperature increase, the aluminum material will take more time, while the lead material's temperature will increase in less time. The aluminum material is like Tank A, it absorbs a lot of heat to increase its temperature by 1 degree Celsius. The lead material is like Tank B, it increases its temperature by 1 degree Celsius with less heat. In other words, to raise the temperature of a 1 kilogram mass of aluminum material by 1 degree Celsius, 897 joule per kilogram degree Celsius of heat is required. To raise the temperature of a 1 kilogram mass of lead material by 1 degree Celsius, 128 joule per kilogram degree Celsius of heat is required. This is the concept of specific heat capacity of a material. Now, what is the heat capacity of the material? The heat capacity of a material is the amount of heat energy required to raise the temperature of the material by 1 degree Celsius. For example, let's take a 7 kilograms aluminum block. The specific heat capacity of aluminum is 897 joule per kilogram degree Celsius. This means that it takes 897 joules of heat to raise the temperature of 1 kilogram of aluminum by 1 degree Celsius. So, to raise the 1 degree Celsius temperature of the 7 kilograms aluminum material is 897 joule per kilogram degree Celsius, multiply 7 kilograms is equal to 6279 joule per degree Celsius. This is heat capacity of a material. Specific heat capacity is a constant value for a particular material, so it doesn't change. However, heat capacity depends on the material's mass and therefore can change. Now, let's see how specific heat capacity is used in HVAC system. In a chiller plant, water is used as the cooling medium and is sent to the AHU. In the AHU, the cooling effect of the water is transferred to the air through a heat exchanger, and the cooled air is then distributed throughout the room. Water at 6 degrees Celsius from the chiller enters the coil of the AHU. As the water travels through each coil, it absorbs heat from the return air and provides good cooling to the return air. Due to the high heat capacity of water, it absorbs a lot of heat to increase its temperature from 6 degrees Celsius to 7 degrees Celsius. Finally, when it comes out of the cooling coil, it has absorbed more heat from the return air and comes out at 10 degrees Celsius. If we were to use a liquid with a low heat capacity, its temperature would increase rapidly, with each degree Celsius of heat absorbed, making it difficult to achieve proper cooling. Therefore, we use water with a high heat capacity in our chiller plants. I hope you understood the concepts of heat capacity and specific heat capacity through this video.